Okay, so we're going to finish up with a couple more examples of fractions that involve factoring. So whenever you see two fractions that are either added or subtracted, before you do the common denominator, there's something you should try, which is what? You have to factor them first, but what should you look for? Maybe one of the two simplify. So you would do that first so that you're not having x cubes and x to the 4 and x to the 5. So you want to see if something will factor right away, and before you do the common denominator, see if they simplify. So simplify before the common denominator. All right. So the top doesn't factor, it's just an x squared. So, I mean, you could write it as x times x if you wanted, but that would be it. What about the denominator, the bottom? Can take out an x. So if we take out an x, we're left with x plus, divide the x out, you're left with a 2. What about the bottom of the second one? How does that factor? Difference of squares. Right? Anytime it's like x squared minus a number, it's a difference of squares. Okay, so now before we figure out what the common denominator is, do one of the two fractions simplify? Yeah, we cancel one of the x's. Like on top here is x times x, and there's just an x on the bottom. But remember, whenever we cancel an x out, what are we going to write over to the side? Whatever it is we canceled. So we're taking out that x on the bottom. What would make that 0? Just 0. So x can't be 0. We need to put that in. Okay, so what's the common denominator now? So the second fraction has x plus 2 and an x minus 2, and the first one already has an x plus 2. So what does the first fraction need?
The x minus 2.
X minus 2. So we're going to multiply by x minus 2 on top and bottom. Stick that in a bracket. Now we have the common denominator, so write it as one fraction. Now what? We've got one single fraction. You leave the bottom, don't expand the bottom. You always leave the bottom in its factored form. Why? We're going to leave that as factors because when we simplify the top, maybe one will cancel out. And also, this is not part of calculus doing what we're doing right now, but it's part of a question, and then you need to then factor it to finish the question. So if you expand it, you're going to have to refactor it. So don't ever expand the bottom. Just always leave it as 2 brackets or 3 brackets, whatever's there. So how do we fix up the top? So multiply the x. X times x is x squared. X times 2 is 2x. And now what do we say? Does the top factor? Maybe 2 numbers that multiply to give 8. 4 and 2. So to give a minus 2, we would need the 4 to be negative and the 2 to be positive. Those add to negative 2, and they multiply to negative 8. So we factor it, Does anything cancel? But we canceled out an x, so we have to write beside it that x can't be, we don't want this to be 0, so that would be x is -2, doesn't work. So we need to add in that x can't be -2, because we canceled that out. So here's our final answer, and our restrictions, one from up above, and one from here, so x can't be 0 or -2. Okay, so as soon as you cancel an x, if you write that restriction, then you go up and look, find all your restrictions, and write them at the end. Yep.
Originally one was section of x over x plus 2 minus 8 over x plus 2 minus, or times
Yeah.
x plus 2. Why couldn't you cancel them like
Here?
yeah.
Well, then you're going back to this step before you put it in. Like you put it in to make a common denominator.
Yeah, okay.
So if you canceled it out, then you're back to this step again. And then you would multiply top and bottom. You want a common denominator. Once the bottom's the same, don't cancel anything out or you're going backwards. Do you know what I mean?
Yeah.
So that people do that. They say, oh, top and bottom, same thing. But you just put it in there on purpose so that the bottoms would be the same. Then you need to work out the top. So don't cancel anything. Right here, why can you not just cancel the x minus 2 in this step? Is that x minus 2 times the whole top? No, it's times part of the top, but not times the whole top. And the only time you can cancel anything is if it's multiplied by the whole thing. This x minus 2 is multiplied by the whole bottom, because it's a factor. These are two factors. How are they related? They're multiplied. X minus 2 is not a factor of the top, because there's a minus 8 here. It is not x minus 2 times something on top. So you cannot cancel it, because there's a minus 8 there.
Can we not simplify them further on the bottom answer?
Nope. Nope, because there's nothing multiplied on top and bottom that you can cancel. That's not x times minus 4. And that's not 2 times x, right? These are added or subtracted. There are two terms on top. They're not, there's no factors. Yeah, so you have to be careful of that.
Can you just get the restrictions how we can remove from the original question?
Yeah.
Yeah. Is that fine with you?
Yeah, because you would just add in an extra. You'd have x is 2 in there as well, yeah, which we'll do later. But yes, you can do that. Okay, so next one. So these two fractions are not added or subtracted, so we don't need a common denominator. So be careful. There's two fractions here, but how are they related, or what's the operation we want to do with them? Multiplying. Multiplying fractions is just like multiplying. When you multiply fractions, what do? No, not cross multiply. That would be very wrong. When is the only time you can cross multiply something? Right, you can only cross multiply across an equal sign.
Yeah.
There's no equal sign in here. That's the next section. So you multiply across the top and across the bottom. So it's like one big fraction. You could actually just extend that line and ignore the plus or the times. That's what it's like doing, okay? So it's you're multiplying these and you're multiplying these like that. Okay, that would be the same question. One great big fraction with all of that. Okay, so what are we going to do here? We are going to factor everything and see if stuff cancels. So the top, x squared plus 4x. Can we do anything? Common factor, take out an x. the bottom. Two numbers that multiply to give 2. 2 and 1, they add to give 3. Both plus. The top over here. Take out an x. Anytime you see an x cubed, remember I said we're not going to do synthetic division, so you're always going to be able to just factor it out. So if we take out an x, what do we have left? X squared minus 2x minus 3. And then maybe that factors, which we'll do in the next line. What about the bottom? Difference of squares. Right, x plus and minus 4. All right, so we still have to factor this if it factors. Remember, this is really like a big, long fraction. So here we've got two numbers to multiply to give 3. 3 and 1. And we want them to add to give a minus 2. All right, so there we go. What cancels? Okay, is there an x on the bottom anywhere? No. What about x plus 4? X plus 1? X minus 3? No. So, right, what's left, what we have on top is x times x minus 3. And on the bottom, x plus 2 times x minus 4. So what x's did we cancel that we'll need to write the restrictions for? A -1 and a minus 4. So x can't be -1 or minus 4. Right, because we had x plus 1 equals 0, which is -1, and x minus 4 equals 0, which is, x plus 4 equals 0, minus 4. Nothing else cancels, so that would be your final answer. And don't expand it, because we're going to use these for something else, and you will then have to go back and factor it again. Okay, so whenever you have fractions that you factored something, leave it factored in the final answer. Fraction over a fraction. What does it mean?
Yep. Multiply 3 minus x over x multiplied by x squared over 3.
Right. Yeah. So this is the same question as if I said that. So the top fraction divided by the bottom fraction. And to divide a fraction, you're right, what do? You write this first one as it is, and what do you do with the second one? Flip it over. The reciprocal. So if we flip that over, now we have 3 minus x times x squared on top, because when you multiply fractions, you just multiply across. Now, they're already factored here. There's nothing further that we can factor, but does anything cancel? One of the x's does. You'd be left with an x. So we have 3 minus x times x on top, and on the bottom 2x plus 1. We canceled out an x, so that would be a restriction of 0. Nothing else you can do. Yep.
What when you put x is not equal, does that always have to be included in the question?
If you cancel an x out ever, then you need to put it, yeah. I'm really, want you to get this part right, but when we do graphing in chapter 2, we need the restrictions, because those are holes in the graph and asymptotes and stuff like that, so it's good to find them. You might as well get a head start, because we're going to have to find them later, so you might as well just do it. Yep. Did you have a question? Or you're okay?
Never mind.
Okay. Okay, ready? Crazy, right? What are your thoughts? What would we do first? So we've got a fraction over a fraction kind of situation here, but up here it was good because it was just one fraction on top, one on bottom. We just flip the bottom one over and multiply. We can't do that here yet. Why not?
We need a common denominator.
Right, we need to join these together so that they're one fraction, join these ones together so that they're one fraction, and then we can do like we did in the last question. So you could do them separate and then put them back together, or you could keep writing the top and bottom. I think separate's probably quicker or less writing, because if you're just working on the top and you have to keep writing this bottom over and over and over as you go down, that's probably not the most efficient use. Or if you're doing them at the same time, I don't know, confusing maybe. So let's do them separate. So let's just call the top here A and the bottom here B, and then we'll put them back together once we get them as one fraction. Does that make sense? All right, so if we take just A, what's nothing factors here, so we don't need to worry about that. What is the common denominator? We want both an x and an x plus 1 on the bottom. So we would need to multiply the first one by 1 plus x. And the second one already has the 1 plus x on the bottom, but it would need the x. So then they have the common denominator where we won't cancel anything. We'll just fix up the top. So on top of the first one, and x times x, x squared. Remember, don't cancel because we just made the common denominator. We don't want to go backwards. So write it as one big fraction. Now, even though this looks like it's factored, the top is not factored here, because we've got this plus an x squared. So the top is not factored. You can't cancel anything out. You have to expand the top, join it all together, and then try to factor. So fix up the top. It is not factored right now. We need to expand this and then add the x squared into it and then factor whatever is on top. So 1 times 1, 1 times minus x. So what cancels on top? Yeah, actually all we're left with is a 1. Okay, so that's A that we'll put back in our fraction after.
Can we do that though? Because there's the 1 at the start that doesn't actually couple with it.
Yeah, so what we have left is 1
Right. but
plus
here-
nothing. If you had x plus 2 minus x, what's that equal to?
2.
Right.
But that's adding and subtracting, you're dividing by x, all those terms.
We're not dividing anything. I'm just saying
I
this
thought
is
you were-
minus x plus x. They cancel.
Oh, okay.
Minus x squared and a plus x squared. Do you see it?
I see what you're saying.
Okay, good. You see it? It's okay to ask, because if you're asking, someone else probably said, what the heck did she just do there? I know what I'm doing, so I don't think to ask. Not that I'm always right. You should see me in my finance course, my third year finance. I make mistakes all the time. Crazy mistakes in these crazy big long questions. And then someone will say, I don't think that was right in step 1, 2 pages ago. Yeah, exactly. Okay, so what about this one? This is the bottom. Same idea, same thing. So we need a common denominator, so we're going to multiply this first one by 1 minus x on top and bottom, and the second one by just an x. These look very similar. Probably similar things will happen. So now we have a common denominator, so we write it as one fraction. Multiply it out. This was here. And that was just rewriting that one. Okay, so what cancels on top here? Same idea. Same thing, I think. The x squared, there's a plus and a minus, so they would all cancel. And we're left with 1 over x, 1 minus x. Oh, interesting. Okay, so we'll put it back together. So a over b, which is the same as taking the top, dividing by the bottom. When you divide by a fraction, you write the first one, multiply by the reciprocal of the second, or flip it over. All right, what do we have left? I'm running out of room, but what you multiply across. So this would be x times 1 minus x over x times 1 plus x. What cancels? The x. So let's just write our final answer here. So the x's would cancel, and our answer would be 1 minus x over 1 plus x, with what restriction? We cancel out an x, so 0. Right. Okay, so anytime you see that scenario, so what was the original question? It had like fraction on top that you had to find a common denominator for, and bottom could be the same, or one of them could already be a fraction and you not have to find the common denominator. You do both parts and then divide it. Now, where I find people go wrong is not in all the complication of simplifying each part. Where people go wrong is that final step when you flip over the bottom. They flip it, they don't flip it over. They just write it, and then the stuff doesn't cancel. So be careful that you're actually flipping that over and multiplying. Okay, and I find what does help is if you write the divide and then write it exactly as it is and then flip it over. So if you're prone to like silly mistakes that you say, oh, why did I do that? and you do that frequently in math, then probably writing an extra step is better for you than trying to do it in one step. Okay? I see people nodding that, yes, I do that in math. Lots of people do that. Okay. So, where's my questions for today?
So would it have been more simpler to get the common denominator at the beginning instead of all these extra steps?
We did do the common denominator.
I know, but you showed each step for each one, but you could have did it at the very beginning, no?
Well, you can do it without writing the top and the bottom separate,
Okay.
right? You could just do it on the top, do it on the bottom as you write them, but you'd have to keep them both together. I would probably do that, but...
So you're saying for like our next test, you're gonna give us like an entire page to write out all these steps?
Oh, yeah, if there was a long one, yeah. Yeah, so I when I do make up the test, and I leave space, I usually print it out, try it, add a little bit of room to my answer, and have you had enough space so far?
Yeah.
Yeah. So I print out a few times to get the spacing right. I usually add a few lines thinking that you guys might write bigger than me or more messy or something. So I try to do the spacing right. But yes, you might have a question at the top of the page and then the whole page. Yeah. If it was a long one like that. I just spent the last hour making up the questions for today, and I seem to have not taken that piece of paper, so we'll make them up. So section, I just made them up, so I'll make them up again. Section 1 point, so 6 is factoring, 7 was what we just did, 8. So solving equations involving factoring. So we did solving equations earlier, and we had sort of 3 types, and you studied that for your test. So the first was just a linear right? How do you solve this? Just put the x's on one side. So minus 2x equals minus 6. X is 3. Okay? So that was the first type without having to factor. So now the first type with factoring would be something like this. So when there's an x squared in it, you can't just move the x's to one side and the numbers to the other side. You have to factor in order to do it. Okay, so we're going to use what's called the zero property. So you've got a quadratic equation on one side, and you have to have it equal 0, okay, not equal a number. I'll show you what happens if it's not equal to 0 when you start, okay. Then you would factor. So then once you've factored, you have two things that are multiplied to equal 0. Now, back in grade 3, when you first learn the multiplication table, the easiest one is 0. Why? Right. And I tell my kids that 0 is a hero. I know, I'm geeky. Because he can make everything disappear, right? When you multiply by 0, no matter what it is, it disappears, right? So he's pretty cocky and thinks he's pretty great. So, that being said, for two numbers to multiply to give 0, one of them has to be 0. That's called the zero property. Either A equals 0 or B equals 0, or both, right? It wouldn't matter if both were 0, because 0 times 0 is still 0. That's called the zero property. So what we do is, if we've got a quadratic equation, we factor it. So two numbers that multiply to give 2, 2 and 1. We want them to add to give a positive 1. So plus 2 minus 1. So what we've got is two things that are multiplied that equal 0. So either x plus 2 equals 0 or x minus 1 equals 0. So these are two answers that if you plugged either one of them into the first, you would get 0 as your answer. Right? So if you were to plug in x is minus 2 into the original, minus 2 squared is 4, minus and a plus. 4 minus 2 is 0, so it works. Same as if you plug 1 in, it would also work. Those are two numbers that you can plug into the original and get 0. Okay, so what if we had a quadratic, like an x squared, in it, but it wasn't equal to 0? Then what do we do? We can't use the 0 property with other numbers, because if I have, for example, a times b equals 2, does that mean one of those is 2? Oh, no. You might be saying, yes, it is, because 2 times 1 is the only thing that gives 2. No, 2 times 1 is not the only thing that gives 2. What two numbers, what are other two numbers that multiply give 2? Any ideas? Yeah, that would give 2. I'm thinking like 1/2 times 4, like 0.5 times 4, right? There's lots of things. 100 times 1 over 50. That would also give 2. There's lots of things that give 2. That does not mean that A or B has to be 2. The 0 property only works if it's 0. So if we had, for example, x squared minus x equals 6. We don't factor one side and then say one or the other has to be 6. That is not a rule. It has to equal 0. So how do we move the 6 so that it is equal 0? Yeah, take it to the other side. So we would, first step is make it into something equal to 0, and then factor and use the 0 property. So we would say two numbers that multiplied give 6, 3 and 2, minus 3 plus 2 gives a minus 1. So this says that x minus 3 has to be 0, or x plus 2 has to be 0. And again, if you plug them into the original, they would equal 6. But you always have to start with equal 0 before you factor something, okay? What happens if you can't factor it? No. If you can't factor it, it doesn't mean there's no answer. Who knows what you do?
Not factorable.
It's not factorable, but remember I said when something doesn't factor, it doesn't mean no solution. I said it before, you then use the quadratic equation. So if you can't factor, use quadratic equation. So what if you can factor? Can you still use the quadratic equation? You can just always use the quadratic equation if you want. The problem is you still need to know how to factor, because there's other questions like simplifying and things that you'll need to factor to be able to do it. So you can't just say, oh, I'm just going to forget about factoring and always use a quadratic equation. You can't really always do that, but what's a quadratic equation? Okay, so here's something that may be factors. It may be factors, okay? But you say, oh, that's one of those ones where I have to do the common, right, the grouping to do the common to find the factor. And I don't like doing that, or I'm not sure how, or I forget how. So now this would be a point where you could just jump to the quadratic equation and say, I don't really want to factor this, even though it might. I can use the quadratic equation and get the same two numbers. Okay, so let's not try to factor it first. So what's A, B, and C? 2, 7, and 3. Okay. So minus B plus or minus B squared minus 4 times A times C all over. Make sure that that fraction goes over the whole thing. Also, take a look at yours and make sure that your square root goes over that whole number. People sometimes stop their square root short. That would get marks taken off because it's not correct. 2 times A. 7 squared. 4 times 2 times 3. 24. 49 minus 24. You can do it out long if you want. 25. Okay. Square root of 25. 5. This one worked nice. That, if that happens, it means you could have factored it. It was factorable. Okay, so if the square root, when you do this, works out nice, you could have factored it. So this could also be used, just doing that square root part, b squared minus 4ac. If you plugged that stuff in there, it'll tell you whether the function factors or not, if the square root works out. Just a little trick. Okay, so this is minus 7 plus or minus 5 over 4. So this gives us our two numbers, minus 7 plus 5 over 4, or minus 7 minus 5 over 4. This one is minus 2 over 4. And this one is minus 12 over 4. These would be our two answers. But I'm going to show you how to use those answers to write the factors. Because you can sort of go backwards. If you know the answers, you can write the factors. So think back. Let's flip back to another page. I'll give you that back in a second. Okay, down here, when I wrote x minus 3 equals 0 and then solved it for x is 3, what was the factor? X minus 3 was the factor. If I had the answer, if I move the 3 over to be with the x, then I have the factor. Or if I have this answer, if I move the 2 over to be with the x, it'll be x plus 2. That's a factor. Those are my two factors. If you know your answers, you can actually go from your answers to your factors. So what's one of the factors here? What's the factor here? Right? Move that minus 3 over to be with the x, and here's one of our factors. Now, the other factor is a fraction. Let me show you how to do that. So, we want to move everything over, but do the cross multiply first. This is a fraction. So if we cross multiply, what do we get? 2 times x equals -1. Follow? And then bring that 1 over. There's our other factor. So if you had done it doing the grouping way that we did in the last section, then you would have got this as your answer. So you don't, so what I'm saying is, if you didn't like that grouping technique, that common, forget it, use a quadratic equation, you can still get your factoring that way. Okay, that's where we'll start next class. We're going to do a few more of these. And then we're going to add fractions and radicals in.